All right, y'all. Today we're going to be talking about combining like terms and how it can help us kind of solve some more advanced um, solving equations problems. So when I talk about like terms, I talk about terms that either just numbers like 2, 3, 4, -6, 7. All those are like terms because they just have our numbers. So like as an example, that 2 and that -7, those are the same kind of terms. I could do 2 minus 7, which would equal -5. The other thing that makes two terms like is if they have the same variable. So like 2x and 19x, 4w and -10w, 32a squared, and 9a squared. So they have to have either no variable at all, so they're just numbers by themselves, or they have that same variable for them to be like terms. Things that are going to make them unlike, of course, if they have different variables, so 2x and 19a. If it's the same variable but different tiers of exponents, so 4w and 10w squared. Or then, of course, if I have a number and then I have a number with a variable, so 2 and -7y, those are not going to be like terms. So if they're not like, I cannot combine them and simplify them. So let's look at an example like number 1. I want to simplify each of the equations. So negative or 1, I have -6k plus 7k. So this one is rather straightforward. K is that like term. So I'm going to take -6k and 7k, and together, -6 plus 7 would make +1. So this is just going to equal 1k. Okay? So relatively straightforward. Over here on number 2, though, now I have 12r minus 8 minus 12. So I'm still looking for those like terms. So first and foremost, do I have anything else like 12r? I do not have any other terms in this expression that has r. So my next step, I'm just going to get 12r exactly as it is. But then my -8 and my -12 are the same kind of terms. So -8 and -12 would make -20. So I'm always looking for like terms for terms that are the same. -8 and -12 do not have that variable r, so they are the same kind of term, while 12r is the only term that has that r variable. So these ones with only a couple terms can be relatively straightforward, but when we look at ones like number 3 and number 4, where we have multiple terms, that's where it can be a little bit more difficult, and we want to make sure that we're checking for all of them. So number 3, we have 2x plus 3y plus 7x minus 2y. So first and foremost, I want to check my 2x. Do I have any other terms in number 3 that are like 2x? I do, and that would be 7x here. So 2x and 7x combined together, positive 2x and positive 7x are going to equal positive 9x. And then my other set of terms, positive 3y and negative 2y. So as I combine those, positive 3y and negative 2y would combine to become positive 1y. And then once again, once I've combined everything, I just have a single instance of each term. I know I'm going to be done with each of my questions. So looking at number 4, we have x squared plus 3x plus 5y minus 2x plus x squared. So first and foremost, that x squared. Do I have anything else that's like that? I do. This other positive x squared. So positive x squared and positive x squared would give us 2x squared. Next up, I have that positive 3x. Do I have anything else like positive 3x? I do. This minus 2x. So positive 3 minus 2, that's going to give me positive 1x. And then last but not least, I do have this positive 5y. Do I have anything else like that positive 5y? I do not. So I'm just going to end up with a positive 5y tacked on to the end, and that's going to be my final answer for this one. So each of these, what I want you to notice about 1, 2, 3, and 4, They are expressions. There are not, there's not an equation, an equal sign. There's not stuff on both sides. When we get to equations, we're actually solving. One of the key things to remember is when I'm combining like terms, I can only combine like terms on the same side of the equation. So I can only combine like terms that are on the left side or the right side, not across sides. And then when I'm moving variables around, I'm moving numbers around, I only want to apply those add, subtracts, or multiply, divides to those like terms. So let's look at an example like number 5. So number 5, we have n plus 4 is equal to 28 minus 5n. And when I have an equation like this, I actually have tons of options of what I could move first. My goal is to get n by itself. And one of the ways we can try to achieve that is by getting all of my n terms to one side of the equation and all of my terms that don't have n to the other side of the equation. And when I'm moving terms to try and get my variable by itself, I always want to try and keep my variable positive because that's going to make my math a little bit easier in the end. So I have the option of either subtracting n to both sides or adding by 5n to both sides. I'm going to add by 5n because if I do that, it's going to give me a positive amount of n over on the left side. So m plus 5n would equal 6n. Then I, of course, still have my plus 4 equals my 28. And if I did my job correctly, that negative 5n and positive 5n are going to cancel out. Now that I've done that very first one, we can see it's a relatively straightforward solving problem from there. So I want to move that 4 and then the 6 multiplied in front of my n. So to move that plus 4, I'm going to minus 4 to both sides. So I end up with 6n is equal to 24. Once again, my 4 and negative 4 are going to cancel out. And then 6 times n, I undo that by dividing by 6. And so we end up with n is equal to 4. So the key to this one is that very first step to move those n's over. But really, really important. Notice when I added this 5n, I added it to the n term. I didn't add it to the 4 because 5n and 4 are not the same sort of term. So I only want to add to like terms. Okay. Now, a little bit different on number 6. On number 6, we have 5x plus 3x minus 7 is equal to 7 plus 11x minus 8. And this time, we have multiple terms on each side. Not only that, we actually have like terms on each side of the equation. So remember, we can only have like terms on the left side of the equation or the right side. We cannot have like terms across our equation. So looking at the left side first, do I have anything else that is like my 5x? I do. I have my 3x. So I'm going to go ahead and combine 5x and 3x, and that would give me 8x. And then, of course, my minus 7 is equal to. So I've combined some like terms over on the left side. On the right side, do I also have some like terms? I do. I have this 7 and this minus 8. So 7 and minus 8, if I combine those like terms, would give me negative 1. And then, of course, I still have that plus 11x. Hey, so we can see I did not combine any like terms. So even though I have negative 7 and negative 1 on both sides of the equation, I did not combine those across the equation. And even though I have 8x and 11x, I'm not going to combine those across the equation. To be able to move things from one side of the equation to the other, we have to actually do our opposite operations. So now I want to try and move some things, and I have the option of moving anything, but I want to try and keep those x's positive. So I'm going to move this positive 8x over to the other side by subtracting it. So minus 8x minus 8x. Over here on the left side, my 8x and negative 8x is going to cancel out. That leaves me with negative 7 is equal to negative 1. 11 minus 8 would be 3. Okay, from here, I want to get those numbers to the same side, so I can add 1 to both sides. And we get negative 6 is equal to just 3x, because that negative 1 and positive 1 will cancel out. And then last but not least, I want to divide both sides by my 3, because it is 3 times x. So I'm canceling out that 3. So 3 cancels out on the left side. On the right side, negative 6 divided by 3 would equal negative 2. All right, so that is combining like terms. So when we're combining like terms across expressions, remember we are just looking for combining any of those terms that are the same in that long string of expressions. We want to combine it until we have a single representation of each type of term. When we are combining in equations, important note is that we cannot combine like terms across an equal sign. We can only combine on the left side of the equal sign or on the right side of the equal sign. And then when we are moving variables or we're moving numbers to one side or the other of the equation, we only want to apply that addition or that subtraction to the like terms on each side of the equation. That's why on number 5, I added 5n to my other n term, and then minus 4 to 28. And then same thing over on number 6. When I minus 8x, I only minus 8x to the 11x. I didn't also do it to the negative 1. I'm only applying it to those like terms. All right, that is combining like terms. Go ahead and complete those workshop stations. Get a little bit more practice.